Hello, everyone. Good morning. I'm here to talk about something that I'm really excited about, AI agents and how are we using them for enterprise-wide automation in e-commerce. What about myself? I'm Viren. I lead the GenAI and ML platform at Flipkart. With over 8 years of experience in the industry, today I'm really excited about the transformative potential of AI in the industry and how they are transforming this landscape. To talk about the agenda over the next 30 minutes or so, we'll cover some key areas. We'll start with a brief introduction of the GenAI platform at Flipkart. We'll dive into the specific part of it, which is the AI agents platform. We'll also discuss how agents are created and how the agent lifecycle looks like. And finally, we'll explore some existing use cases that we have powered on top of this platform. And if time permits, we'll have some, Q&A session at the end. To set the stage, let's take a high-level look at the GenAI platform. On the screen, as you can see, we have various data sources on the left, which feed into the orchestration service for feature engineering and ETL jobs. We have a suite of managed services for GPU engineering, which is on both like on-prem and on cloud. And our core services include model training, hosting, and etc. On top of that, we have core services like fine-tuning, RAG as a service, vector store, and whatnot. All the LLM calls pass through our GenAI gateway, which has an integrated AI safety layer, ensuring security and governance. And then on the right, you can see the applications with the platform powers. These can be chatbot, support system, content generation system, search and record systems, and whatnot. But for this talk, we'll be focusing mostly on the central piece, which is the AI agents platform. Okay. Before we go into the platform, I'd like to share, a journey. Our journey to this platform started with a simple RAG as a platform. So we were exploring a variety of use cases such as catalog semantic search, multi-modal search, policy bots, SRE bots, and whatnot. Well, these solutions delivered relevant responses, but their scope was limited to available data sources. To enhance the capabilities, we developed sync systems that could take actions based on user inputs. Some of the use cases were a CSV agent or a RAG agent, but these could not handle the complex tasks. In order to do that, we had to upgrade to multi-agent workflows, enabling us new possibilities and streamlining the interactions between the agents. Now, what is agentic AI? Let's understand that a little better. The traditional use of LLMs relies on a zero-shot paradigm, right? What that means is you prompt the LLM with something like, "Hey, can you give me a Python code?" Right? And the LLM generates that entire solution sequentially from start to end, all in one go. The results that are produced are usually acceptable, but they don't have any internal validation or they can't use external context. But with agentic workflow, this entire story changes. In an agentic workflow, it will operate with you giving AI a comprehensive task list, right? The AI will first come up with an execution plan, and maybe you'll tell him, "Hey, if needed, please use this web research tool, or maybe the RAG tool to fetch external resources." And the generated code will subsequently be passed to, let's say, a critic agent for analysis, error correction, and optimization. And this iterative loop of cognition, tool use, and revision, though might be more latent, but significantly enhances the quality of final output that is generated. So, what is actually a AI agent platform? Let's look into the building blocks of it. There are mainly six core components. It starts with the orchestration layer, which is the nervous system managing complex coordination of interaction between agents, tools, and the models, which ensure a coherent task execution. And obviously, the autonomous agents, these are the core decision makers, self contained programs capable of complex directives, formulating the plans, and driving task completion. The tool interface, these are the functional extensions, right? Callable modules, be it an API call or database connector and whatnot, that grant agents the ability to safely connect with external systems. And obviously, the models, the LLMs, that serve as the reasoning engine powering agents' comprehension and planning capabilities. With this, you'll need a memory management, which is a critical subsystem that maintains and retrieves relevant temporal context to ensure that the agent continues in a context-aware interaction. And finally, a knowledge base, which expands the inherent knowledge of LLM with either proprietary data or any external information. Now, by providing all these core components in the platform, we can develop and deploy AI agents that solve a wide range of business problems. Let's take a sneak peek into the architecture of this platform. On the left, you'll see the client applications. These can be anything from web app to REST APIs or an SDK, right? The user starts by creating core components that they need: the agent teams, the individual agents, the tools, and the models. The heart of this entire application is the core engine. It provides templates like core agents for specific tasks. This could be BigQuery agent or a RAG agent. And this core engine is also responsible for managing transactions and state management. State is used to manage information that is relevant only to current conversation. With this, an agent hosting platform is a robust hosting environment where agents can be deployed independently on heterogeneous compute. Be it you get hosted, you want hosted endpoints, you want to inference your SLMs locally, the environments, the backend server, be it VLM or whatnot, and with all the build options intact, right? The memory can be short term, long term, which helps the agents maintain that context beyond immediate conversation, and the agent's knowledge base, which is built on top of a vector store and an artifact store that supports a wide variety of data sources. Now, a key design principle that we needed was flexibility. We did not want to limit our design to a single framework. So, we chose a framework agnostic approach. We have defined these standard interfaces of the core components, and these can be implemented in multiple frameworks. We started the implementation in Autogen and Google EDK, but this design helps us to extend it to any framework in future. The platform supports tools such as uh, function tools that execute Python function, an MCP tool that can talk to any external MCP server, or maybe A2A, which enables agent to agent interaction. All of our models, both commercial and LLMs, the in-house ones, sit behind a unified GenAI gateway. Now, this gateway is part of an integrated ecosystem where you can fine tune a model on the training platform, push it to Model Hub, and host it securely. Most importantly, our AI safety layer is embedded directly into this gate. And of course, for any production grade system, observability is non-negotiable. Our platform supports all essential constructs, be it logging, monitoring, or telemetry. And finally, evaluations are a core part of building reliable AI agents. The platform allows us to evaluate the trajectory of agents, and to check whether they took the intended path, and also to evaluate whether the tools they used were called correctly. With that, let's take a look into the agent SDLC, how agents are built. Okay, so in order to get started, you'll first set up the environment, which is all about acquiring the requisite packages and libraries for agent development. And then you would develop the agentic workflows using the chosen frameworks and implement the inter-agent communication protocols, such as A2A. As the next step, you would want to evaluate the agent performance to check goal adherence, whether they are doing the intended task, whether the results are accurate enough. And once the evaluation metrics look good enough, you would want to deploy the agents, ensure a proper dependency injection for the runtime and the tool execution, while maintaining a control over resource allocation. And after a successful deployment, you expose the agent via stable endpoint, utilizing communication protocols such as WebSocket, server-sent events, REST API, whatnot. All of this, you'll want to manage the agent lifecycle as well as the deployment with the RBAC. And this is not like a one-shot process. You have to continuously repeat the cycle of development and evaluation to incrementally refine the agent until optimal results are obtained. And implementing monitoring across all the stages is essential, be it the development stage, the evaluation stage, or post deployment stage, to gather the right metrics that are essential to take informed and strategic decision making. Now, let's take take a look at the steps involved in building an agent. The step one is, you started by uh, architecting the workflow by clearly defining the roles of constituent agents. So one principle that we use is a single responsibility principle, which is uh, a better performance is achieved by designing specialized agents when every agent have a dedicated distinct function rather than creating a monolithic of complex and multi-step operations. The number of agents could be ranging from a handful or a highly distributed system depending on complexity of the system. uh, the pattern what is also essential is following cognitive architectures. So there are few known agentic design patterns. These could be the reflection pattern where a critique agent defines the output of the generation, or a delegation pattern where the master agent decomposes the complexity and distributes sub-agents to specialized workflows. Once you have defined your workflow, the next step is to select an agent framework that is optimally aligned to your use case. For scenarios demanding explicit graph-based orchestration, you might want to choose LangGraph, or maybe for use cases that rely on dynamic model-driven handoff, maybe OpenAI Agents SDK is a suitable choice. But if you're looking for enterprise-ready solutions that require evaluation through artifact management, a robust deployment pathway such as Google EDK might be, the right choice for you. And there's no universally optimal solution. The selection must be deliberate and informed based on purely agentic and the technical use cases that you need to power. And finally, and the most important step is the selection of the LLM, which functions as the cognitive core of your agentic system. The choice must be aligned with your use case. And there are like N factors that you can take in, which could be the speed, the accuracy, the tool selection, and the execution, the cost efficiency, or maybe the task completion rate. And options, as you would know, are plethora of them, be it OpenAI, GPT family, Claude's family, Google's Gemini family, or maybe the open source alternatives such as Llama, DeepSeek, and whatnot. So now we have taken a look into the steps that are needed for the agentic platform. Let's take a deep dive into the use cases that we have powered on top of this platform. This starts with first the RCAI agent. Uh, Now, to explain the problem, this is a manual. The existing solution was a manual root cause analysis, where let's say the business analyst has to answer a question such as, "A, why there was a GMV drop on a specific date?" And our solution to this was, can we teach an AI agent to detect, the sales pattern automatically and generate hypotheses out of it? The results were incredible. We were able to reduce the RCA time for this from days to minutes. Let's take a sneak peek into how this works. When a user query comes, which is, in form of, hey, can you check GMV drop or order drop for a specific date? A group of agents kick in. The intent detection agent and the entity recognition agent kinds of tries to understand what the user is asking about. For example, the intent might be to find the root cause of GMV drop, and the entities could be, hey, what is the product category and what is the duration? And next, an anomaly detection agent checks for anomalies based on correlation analysis. This information is then passed to planner agent, which creates a plan for root cause analysis. And the core of the solution is hypothesis tree evaluator agent, which uses an NLQ to SQL agent to form queries from the NLQ, fire it on top of the data platform, fetch the exact data, and then do an hypothesis evaluation saying, hey, whether this hypothesis hold true or not. And once the root cause is identified, a historical incident agent would check, hey, have I seen this incident sometime before? Or to find, possible remittance action that can be taken. And finally, a comprehensive root cause report is generated and shown. With this, we were able to significantly bring down the effort and time that it took for an analyst to, go from a manual RCA to a AI-powered chatbot where the entire RC process could be automated. The second use case that I want to talk about is slightly different from this one. That is about code migrations. Now we have all, seen this problem of how legacy codes are, and just upgrading that Java version from Java 8 to Java 17 is painful, right? There's a lot of repetitive testing that is needed, and there's no really value add in terms of, features that are getting added. You just need to kind of comply to the version upgrade because the older version is EOL now. What we tried was we wanted to check whether we can teach an AI agent to understand the code and to understand the unstructured logs that are generated from a build failure. And from those logs, analyze the code issues. Maybe if you the AI agent can recommend a solution and also generate the right code for the fix. The results, we were able to migrate 100 plus repositories with 38% of auto upgrades. What that means is that in these migration, 38% part was driven by the AI agent, but the rest of 70% was still the deterministic flow for code upgrades. How we did this? It starts with the code upgrader agent, which would first retrieve the target code base from GitHub for deterministic upgrade and run that CI pipeline. And then an AI log analyzer would aggregate and analyze the build logs from this CI run. An issue identifier agent would extract and structure the relevant context information and failures from the error logs. A root cause analysis agent would just validate, hey, have I seen this issue before? And can I, find out what is the root cause of this particular error log? And then a fix generation agent would formulate a potential fix based on the knowledge it has, the previous issues it has fixed, and it would also provide necessary corresponding metadata. Then a recipe identification agent will identify an optimal recipe to fix this particular issue. And all of this kinds of runs in an iterative evaluation loop where which runs until we have identified all the issues and all of them are resolved. And finally, PR agent would run all the test cases and will raise the PRs for a human to review. So we have taken a look at two use cases. I quickly want to cover a third use case, right, which I think most of you would already be aware of, is using AI agents in customer support. So Flipkart kinds of handles thousands of seller requests, and these kinds of have like really huge volume during sale events. So what we did was we wanted to check whether as soon as an ticket is raised, can an AI agent look into a ticket and just check into this looks like a general query that is there, and maybe can I find the right SOP for it and also execute the SOP so that a human agent need not take this action in the graveyard shift, right? And obviously when the in the during the sale events when the volume is so high. The results, we were able to reduce actual human interaction contact needed by 20%. How did we do this? This would start with a resolution orchestrator, kicking in as soon as the ticket is raised. And then there would be an incident passing agent, which would first identify the incident type, which also talks to an attachment analyzer agent to thoroughly examine the attachments that are there. These could be screenshots, files, documents, and whatnot. And then a data fetch agent, which retrieves all relevant data from that incident. It talks to the GraphQL queries from the seller system to find the relevant data. The SOP executor agent next identifies the correct SOP that is needed to resolve this incident and systematically executes each step of that SOP. Upon SOP completion, the summarizer agent would, generate a comprehensive summary of all the actions that were taken. And finally, this agent would kind of, summarize the solution and finally close the ticket with all the actions that were taken. With this, let's take a look into how the agent platform looks like. What we have, okay, what we have implemented is a drag and drop UI where the user would go first and select the framework of his choice. He can create a new team, right? Essentially, you can choose what type of workflow do you need. Do you need an LLM backed orchestration or just a workflow agent? You can drag and drop maybe the agents, models, or tools that you have already created in your registry, right? Then you can go ahead, open the form, and maybe if you want to attach a new tool, right? In this case, let's say if it's a function tool, then it's a Python function that is getting attached, and maybe you can write it and attach it to your agent. Also define the dependencies of the function. Or another case, if it is an MCP tool, right, you can just configure what type of protocol is it, or what is the MCP server URL looking like with the optional parameters, and then you just go ahead and save the changes. When this entire recipe is done, you would just maybe create that agent team. And as soon as that agent team is saved, right, it gets persisted in your component registry, and you can go ahead and initiate a chat. Let's take a look into how the chat playground looks like. Now, in order to try out the chart, you just trigger it with an input query. In this case, right, as soon as the query is triggered, a group of agents have started, and you can see them into action. This will actually take some time because it is using a tool called to fetch the actual data from data platform. It would go and fetch the relevant data from data platform that is shown in a tabular and a graphical manner. The agent would then show you a plan that, in order to achieve my goal, this is what I'm planning to do. The beauty of this solution is it can actually take, the human feedback while the workflow is running. So in real time, you can go and say, hey, your plan looks good, but I just want you to add this one more thing. Can you do that for me? And you'll be able to see that, it includes that feedback in the real time. And finally, taking that feedback in, it would go ahead and complete its journey. Finally, it would present a report, saying that to me, it looks like this is the root cause of the problem that you are trying to find out. And it will back all of its findings with the real data and data points that it's fetched from your systems. Okay. What I've shown you is the platform that it exists today. But we are just getting started with this. We have a bold vision for future, and our roadmap is packed. I just wanted to share a glimpse of what is coming next. We are planning to extend this current understanding of text, images, and PDF to a multi-modal support to include audio, videos, and other modalities. Agent batch pipelines. We believe this will enable users to process massive data sets and execute long-running agentic tasks. MCP server registry, we are visualizing a central registry for all the relevant MCP servers, creating a unified catalog of the context that is spanning across the entire ecosystem. This could be from the data platform, catalog platform, and whatnot. Agent Garden is a vibrant marketplace for agents where user will be able to publish their creations and others will be able to discover and use them. Each agent can have a detailed agent card showcasing its capability, make it easier to find the right tool for the job. Agent Copilot is more of a meta agent to streamline the agent creation process. Think of it as, I'm coming to the dashboard and I'm using an agent to create the other agentic workflows. And then we want to venture into, fine tune specific agents specifically for proprietary use case or domain requirements. In conclusion, I think AI agents are transforming the way we are taking decisions here at Flipkart. The future is great and we are just getting started. That's all I had. Thanks for your time. I'll be happy to answer any questions that you might have.